moving right along, number 13. All right, the graph of f prime of x is shown. I don't know why this is a typo. The graph of f prime of x is shown below. So this is the derivative. So that means, let's just talk about what that means for a second. Let's pick a point right here. I'd say that's about -2. What that's saying is that the graph of f has a slope of -2 at approximately x equals -2. That's what that means. The slope of the line is -2 at x equals -2. Okay. So pick a different point. Let's say right here. This is saying that the slope of the line, or the slope of the graph at, I'd say about 1.5 on the graph of f is -4. It has a slope of -4. Right, so it's decreasing at 1.5. All right, describe the locations of any relative extrema. Well, the graph that we can't see is f, so if it has a max, then the derivative should be positive and then negative and cross through 0. And if it has a min, it should be negative and then positive and crosses through 0. So we're looking for places on the derivative graph where the graph has positive values, crosses 0, and then negative values, or negative values and then crosses through 0 and then positive values. So that's going to be here and here. This one goes from positive values to negative values. This one goes from negative values to positive values. Alright, the one in the middle at 0, the graph doesn't change signs, so that's not going to be a max or a min. So we have a relative max or a local max. At x equals -2. And we have a relative min at x equals 2. How many points of inflection does the graph have? Alright, well, point of inflection is when the second derivative changes sign. The second derivative. So let's use this graph of the derivative to talk about the sign of the second derivative. Alright, so let's see, the second derivative is going to be negative here because the graph is decreasing. Oops. Alright, so from negative infinity up to, I'm going to call that negative 1.5 since it doesn't tell us exactly. Alright, we have a negative slope. Alright, from negative 1.5 until 0, we've got a positive slope. Every time. Slope is 0 right there at negative 1.5. Alright, and then we've got a negative slope again. From 0 to 1.5. Gosh darn it. Alright. And then a positive slope from 1.5 to infinity. Ran out of room. Alright. How many points of inflection does the graph have? Anywhere where the graph changed directions is where the sign of the second derivative is going to change. Right? Anywhere where the derivative graph changed directions, we had a change of sign. Right. So we have 1, 2, 3 points of inflection. Or if you look at them on the graph, right, they're going to be here, here,